So in a problem like this, it says the system of equation below has infinitely many solutions. Enter a value for Q that creates this situation. So what we're going to do is remember that in order for something to have infinitely many solutions, we need to end up with a true statement. So in that case, we're going to go ahead and try to set up this system to be solved for to figure out what the value of Q needs to be in order for it to lead to infinitely many solutions. So let's just go ahead and solve. We have 3x plus 2y equals 6, and we have 10.5x plus 7y equals Q. So normally what you would do is decide, do you want to eliminate the x's or do you want to eliminate the y's? In this case, I think it's going to be our best bet to just go ahead and eliminate the y. So in that case, I'm going to go ahead and multiply the first equation by a 7 and the second equation by a 2. Since both are the same sign, one of them has to be negative, so I'm going to go ahead and make the 2 negative. So let's go ahead and distribute. Now we have 21x plus 14y equals 7 times 6, which is 42. Now on this hand, we have negative 2 times 10.5. That's going to be a negative 21x. Negative 2 times 7y is going to be a negative 14y. And then here, negative 2 times q equals a negative 2q. So what's nice here is these eliminate, leaving 0. These eliminate, leaving 0. So we need this to also equal 0 for it to be a true statement. So what I need to do now is find a way to make 42 plus some number to equal 0. Well, the only way to do that is if you can make this term a negative 42. That way, 42 minus 42 will be 0. So in this case, we want the negative 2q term to somehow equal a negative 42. So what you're going to do is divide both sides by a negative 2, leaving us with q equals, the negatives cancel each other out, leaving me with 21. So in order for this to be true, this q has to be a 21 so that 42 can eliminate to 0. So I'm going to go ahead and say q equals 21. But real quick, let me just check that out. If I do a negative 2 times a 21, let's see, that's going to be 2, that's going to be 4, and this is going to be negative 42. So real quick, if I replace this with a negative 42, would it work? Well, let's see, 42 minus 42 is 0. There you go. This would lead to infinitely many solutions. So for sure, Q is going to have to be 21. Now, a very common mistake is students are going to think, well, I'm just going to go ahead and set negative 2Q to 42. And they end up having a negative answer. So you need to be careful. If you want to make sure it actually eliminates, plug it in for Q and see if this will actually create a true statement with the rest of the system.